and too many ways to find information, and that can be overwhelming too. So I'm gonna try to not overload you on the like videos and everything else, because I would watch my mini lesson video first, and if you needed anything extra, I would look at the other stuff. But don't get overwhelmed, okay? Don't like overload it. If you get too overwhelmed after you watch a video, just send me a message to be like, can you please just help me? All right. All right. So I'm gonna try something different today. Hey Tanner, there's my favorite redhead. What I'm gonna do is have you actually look at some examples I'm gonna write on the board. So raise your hand if I can see your face. Are we on a grid view right now? Okay, Curtis says yes. Okay, if I hit this button, tell me. Yes, Kyle. You raised your hand on the button. That was funny. Sorry, that got me tickled. All right, I'm sorry. It doesn't take much to make me laugh. All right, so I'm pinning myself to the screen. All right, now type me a little message in the box, somebody, if I am the only thing you can see. Or can you still see the grid view? Anybody?
It's still grid view.
Okay, so what I want you to do is this. I want you to go to my picture, and I want you to push or hit that little pin button.
No, it's a cute dog.
I think that'll help. Does it give you an option to do that?
That's not true. Most dogs.
Okay, so if you'll hit that, I think I can actually change it to auto as the grid view, but I want it to be to where I'm like on the big screen, so you can actually see what I'm doing. All right, anybody not able to get theirs like that, and I'll try to do something on this side. Y'all are the experimental group. Okay, good. Curtis says it works. Hannah said yes. Kyle says yes. Tanner, are you able to get it that way, Kaylin?
What are we even doing right now?
I'm gonna try to change it on mine. Spotlight sidebar. Yes. Okay. Good. Sorry, I'm being a little bit weird. No, I don't want that. I don't know what I just did. I may have just screwed it up. Hang on. I'm sorry. I think I just screwed it up. I'm trying again. Okay, go hit the little pin button and it will pin me to the, if you have to redo it, I'm sorry. I was trying to do something on my end and I messed it up, I think. Okay, go ahead and pin that, and I'm going to actually try to get up and talk to you from the board. All right, if you've got me on the big screen, can you see what's behind me on the board? Sort of. Decently. Okay, yes, good. All right. Okay, I'm going to go ahead and stand up here and then talk, all right? Caroline, do you mind closing the door, please? All right, so this lesson is about multiplying matrices, and we've already done add and subtract and scalar multiplication. Now, scalar multiplication is just like taking a number that's outside the matrix and multiplying every number in the matrix by that. But that's literally called scalar multiplication, right? It changes the size of the matrix by a certain amount. This is straight up matrix multiplication. So it is a different process, and it is very much more involved than just multiplying by a scalar. All right, so if you are multiplying matrices, there's a couple of things you got to make sure that are happening. One of them is, can you even multiply? All right, so that's the first thing you got to figure out is it even possible? So what you have to do is look at the problem that you're given, look at the matrices you're given, and make that decision. And how you do it is you look at the rows and the columns of each matrix. Now, if y'all have a question, unmute yourself and then chime in or type something in the text box. I can still see it from here, okay? All right, so matrix A. Y'all can type it if you want to or say it. What's the dimensions of matrix A? Two by two, that's right. All right, what about matrix B? You can see it. Good, it's 2 by 3. All right, so we've got matrix A of a 2 by 2. Matrix B is a 2 by 3. Now, how do you know if you can multiply two matrices together? Well, this is the rule, okay? The rows and columns of each are looked at, okay? The columns of the first matrix have to be the same as the rows of the second. The columns of the first matrix have to be the same as the rows on the second matrix, okay? So are 2 and 2 the same? Absolutely, okay? So this matrix is going to be defined. This multiplication is going to be defined. My question is, what's going to be the size of the answer? The size of the answer matrix. Here's how you figure it out, okay? If the columns of A are the same as the rows of B, the matrix answer will be a 2 by 3. Okay, so I do like a really visual comparison of how to find out the size of the answer matrix. Okay, so if these two numbers are the same, the answer matrix is this big. That's what I'm trying to say. So it's going to be a 2 by 3 for an answer. Now we're not doing it. We're just trying to figure out, can you multiply them and what would be the answer if you did. You got a question on that? We're about to do another one. We good so far? All right. Nobody's saying anything, so I'm going to keep going. All right, so let's look at it the other way, okay? Let's look at B first. Now, you told me B was a 2 by 3, and you said A is a 2 by 2. So here's my question. Do these numbers match? Are the columns of B the same amount as the rows of A? And the answer to that is no. If these numbers are not the same, you cannot multiply these matrices. So this multiplication is not defined. So you would just say something like no solution, I guess, or undefined, something along those lines. Okay. So before you can even multiply matrices, you got to figure out, can you do it? All right. Somebody give me a yes or no in the text box so I'll know what's going on. Does that make any sense about how you decide if you can multiply them or not? It makes sense. Yes, yes. All right. C. Thank you, Tanner. C. Okay. So we figured out how you decide if you can multiply them. So now we actually got to do one. Okay. But before we do that, I want to actually ask you a question. All right. So, you know, in the real number world, let's say I've got like 5 times 2. Is that the same as 2 times 5? Well, yeah. All right. Because multiplication is commutative. But here's the thing. Is multiplication commutative with matrices? No. All right. So they don't follow that real number rule that multiplication is commutative. That's something that I'll have to maybe explain more later, but it is something that I asked you about in an assignment, okay? All right, how's this problem looking? Y'all still see that okay? I tried to figure out where my range was on the board before y'all came on. All right, it looks like I can see it on my screen, so I'm going to go ahead and go for it, all right? You don't have to write this down if you want to. You can just watch. You can go back and look at my other video if you want to. All right, later. So here's what we're going to do. Before we even multiply these, we're going to figure out, can we? All right, well, A is a 2 by 2. And B is a 2 by 2. So before you even start, you've got to decide, is it even possible? And is it possible to multiply these matrices? Absolutely, because the columns of A are the same as the rows of B. So if that's the case, then what's the size of the answer going to be? I may be out of my range here. The answer is going to be a 2 by 2. All right. So when you're multiplying square matrices, you're just going to get the same size answer. That makes sense, right? So a 2 by 2 times a 2 by 2 is a 2 by 2. All right. Okie dokie. So here's what I'm going to do. I'm going to make a really big matrix right here, and I'm going to label some stuff. Okay. And if we're going to get a 2 by 2 for an answer, that means we're going to have 2 rows and 2 columns. So I set it up like this, and then I'm going to fill it in with what goes where, right? But I have another way to do this that might help you, all right? This is the first time you've ever seen it, so we're definitely going to do it this way. But after you kind of get rolling with it, if you don't have to do this, it's okay. But in my past experience, it always helps. All right, so look, this element right here is row 1, column 1. I label it R1, C1. This is R1, C2, isn't it? This is row 1, column 2. This is telling me what to multiply. All right, then down here, this is row 2, column 1. And this last one is row 2, column 2. Okay? So why are we doing that? When you multiply matrices, you multiply the rows of the first one by the columns of the second one. I'll say it again. When you multiply matrices, you multiply the rows of the first times the columns of the second. So we're not using some parts of this and some parts of this. We only use the rows here, columns here. All right, so watch this. Row 1, column 1. The answer that's going to go right there is going to be this. I'm going to multiply this row by this column, one element at a time. So I'm going to do 2, the first element in this row, times the first element in this column. So 2 times 7, that's 14. Write that number down. Okay, now if you've got more numbers in the rows and columns, you got to keep going. So I'm going to move to the next number in the row and the next number in the column and multiply those. So 0 times 8 is 0. Put those numbers there. Talk to me if you got questions. The first row times the first column completely. That's all we did. It's weird, I know, but y'all are going to get the hang of it. All right. I'll keep going then, I guess. All right, now I'm looking at this next element. It tells me it's the first row and the second column. So I'm going to multiply the first row in A times the second column in B. Those little labels tell you what to multiply from each matrix. It really, really helps. All right, so here we go. First element in this row times the first element in this column. 2 times 5 is 10. Write it down. You're going to add to it the product of the next elements in the row and the column. So 0 times 2 is 0 again. Okay, we're going to clear this up in a minute. Somebody give me a note, let me know you're alive, because I can't see y'all's face and nobody's typing anything. We're alive. Thank you, Hannah. Okay, you're alive. That doesn't mean you're thriving, but okay, I'll settle for alive. Okay. All right. You got a question? Anybody? Talk to me. Anybody got a question? All right. All right, so the next in my answer matrix, the next thing it says, this is row 2, column 1. So I get row 2 from A, column 1 from B, and I'm going to multiply those. All righty? So here we go. 3 times 7, that's 21. Add to it the product of the next elements, okay? -1 times 8 is -8. So I did row 2 times column 1. The only thing we got to do now is the last thing. Row 2 times column 2. So I want row 2 and then column 2 from B. All right, here we go. So 3 times 5 is 15. First element times the first element in each. Plus, and notice I'm always adding. -1 is the next element in the row. Times 2 is the next element in the column. So that's -2. All right, so we've got all the products in there. We've got the sum of those all going. We just got to clean it up, okay? So the first element here would be a 14. The next element in that row would be 10. Then the row 2, that would be a 13. And then the last one, honey, would be a 13. All right, so that would be your answer for A times B. Okay, I've already used quite a bit of time, and I don't want to use any more. So here's what I want y'all to do. I want you to go ahead and leave if you don't have any questions on that one. I think some of you actually would probably be ready to go. I'm going to sit here and wait. If you've got questions, pop back on. But if you don't, hop on out of this room. And I'm here if you need me. So let's just kind of treat this as like